So hello dear student. Today we are going to discuss about a very important subtopic in the inverse trigonometric function, that is nothing but the summation of inverse trigonometric function series. In this particular chapter we will discuss the concept behind it, as well as we will solve lots of questions based on the inverse trigonometric function series. We will solve all the questions of all the possibilities in this particular chapter, right? So let us move on to this chapter. Summation of inverse trigonometric series. So what are the formulas associated with this particular series as well as the questions? So there is only one formula related to this that we will use in all the cases. That is nothing but the tan inverse A minus B upon 1 plus AB is nothing but tan inverse A minus tan inverse B. Basically one term will be given and I have to convert this term into the difference, that is known as method of difference. So basically we have to convert inverse trigonometric function as a difference of two inverse trigonometric functions such that they will cancel out. This is known as method of difference. So how to utilize this method of difference, let us discuss in the next question. Find Sn, which is nothing but the summation of r from 1 to n, tan inverse 1 upon r square plus r plus 1, and also find the summation up to infinite terms. As we discuss right now, that formula of tan inverse a minus b upon a plus ab, 1 plus ab, is nothing but tan inverse a minus tan inverse b. I have to use that formula in this question. So what is Sn given? Sn is given summation of r from 1 to n, tan inverse 1 upon 1 plus r square plus r. Can I write this term as in this way? If you notice, what is denominator? Denominator is 1 plus ab, right? So 1 is already mentioned. Can I convert it into ab? What I will do, in the last two terms in the denominator, can I take anything common? I can take r common. What left? R plus 1. Again, can we identify here a and b such that numerator must be the difference of a and b? So what you will say, that I can write numerator as r plus 1 minus r, so that r cancel out, I will get as 1 again, right? Using the formula, can I say that this is nothing but tan inverse r plus 1 minus tan inverse r. Is it correct? Which formula I use? I use the first formula, which is nothing but tan inverse a minus b upon 1 plus ab is nothing but tan inverse a minus tan inverse b. So I convert the term as difference of two inverse trigonometric functions. Now I will put all the values one by one. If I put the first value, what I will get? I will write here. If I put the first value, I will get Sn as tan inverse 1 plus 1, which is 2, minus tan inverse 1. Put r as 2. What is the next term I will get? The next term I will get as tan inverse 2 plus 1 is 3, minus tan inverse 2. Again the next term, put r as 3, tan inverse 4 minus tan inverse 3. Put the last term. What is last term I will get? Tan inverse n plus 1 minus tan inverse n, right? What is previous term I will get? The previous term I will get as tan inverse, put n minus 1. So n minus 1 plus 1, that is nothing but n, minus tan inverse n minus 1. Check any terms cancel out on addition. I can say tan inverse 2, tan inverse 2 cancel out, tan inverse 3, tan inverse 3 cancel out. So tan inverse 4 will cancel out with the next term. Tan inverse n is cancel out with the previous term. Tan inverse n minus 1 will cancel out the previous term. So how many terms left? if one term left in the starting, one term will be left in the ending also, right? So number of terms left are nothing but two terms, which is nothing but tan inverse n plus 1 minus tan inverse 1. What is tan inverse 1? As we already know, tan inverse 1 is nothing but tan inverse 1 is pi by 4. So this is your answer. I also have to find the summation up to infinite term. So as we already know, what is Sn? Sn we got as tan inverse n plus 1 minus pi by 4. Put n as infinity. So tan inverse infinity plus 1 will be infinity minus pi by 4. What is tan inverse infinity? That is pi by 2 or not? So pi by 2 minus pi by 4. Answer will come as pi by 4. 90 degree minus 45 degree is nothing but 45 degree. So I got Sn also. I got S infinity also. This is how to solve the questions on the I.T.F series. Only one formula is there. Tan inverse A minus B upon 1 plus AB is equal to tan inverse A minus tan inverse B. So in these type of questions, whenever you will get the summation of the I.T.F series, try to use the difference method. How to create the difference? This is a procedure to create the difference. Moving on the next question. See the next question. 50 summation of n equal to 1 to infinity 1 upon pi summation again k equal to 1 to infinity cot inverse 1 plus 2 under root of summation r cube. So first I will solve this particular value. That what is the value of summation of r cube? So as we know, summation of r cube is nothing but I started from 1 to k. We have the formula. What is formula? K into k plus 1 by 2 whole square. Now whole square under root cancel out. 2 to cancel out. What left? 1 plus k into k plus 1. So that value I will put here again. 50 summation of n from 1 to infinity 1 upon pi summation of k equal to 1 to infinity cot inverse 1 plus k plus 1 whole power n. Again, can I convert cot inverse in terms of tan inverse? What is the answer? Tan inverse, it's reciprocal. 1 upon k plus 1. Don't you think it became previous question where we solved? So can I write this thing as n equal to 1 to infinity 1 upon pi summation k equal to 1 to infinity tan inverse k plus 1 minus k upon 1 plus k plus 1. I just have to create the difference method to solve this particular problem. Now this is again the formula. Which formula it is? Tan inverse a minus b upon 1 plus ab. The formula is nothing but tan inverse a minus tan inverse b. I will use that formula again. So what is the answer? Tan inverse k plus 1 minus tan inverse k. If I put the values, what I will get? If you remember the last question, what is the answer we got? The answer we got as pi by 4, right? This 1 pi, this bracket will be inside. Whole power is n. Now pi and pi will cancel out. What left? 50 summation of n equal to 1 to infinity 1 upon 4 to the power of n. So can I say that this is nothing but the summation of GP up to infinity term? What is formula? Summation of a to the power of r from 1 to infinity. Formula is first term upon 1 minus common ratio, which is nothing but the a. I will use the same thing here. 50 into what is first term? Put n equal to 1. I will get 1 to the power 1 upon 4 to the power 1 minus 1 upon 1 by 4. Take the LCM. 50 into 1 by 3. 4 and 4 cancel out after taking the LCM. So answer is nothing but 16.66. Or we can also say that 16.67. This is your final answer. So this is how to solve this particular question, which is nothing but a summation of chord inverse series. How to solve chord inverse series? Convert into tan inverse series, and the only method is nothing but the difference method. Use the difference method to get the answer. Moving on to the next question. Tan of summation of tan inverse 2r minus 1 upon r square plus r plus 1 into r square minus r plus 1. Don't you think it is any formula? R square plus r plus 1 into r square minus r plus 1. Which formula it is? It is nothing but r to the power 4 plus r square plus 1 minus 2r cube. Again, can I write this as 1 plus r to the power 4 plus r square minus 2r cube? Anything we can take common from the bracket? Can I take r square common? What left? R square minus 2r plus 1 left, right? If you notice, if I say these are two terms where this is a, this is b, don't you think it is written as difference of a minus b? So what we can do? Can I write the numerator as r square minus 2r plus 1 upon 1 plus r square minus 2r plus 1. Again, it is nothing but the formula. Which formula? Tan of summation of r from 1 to 31 tan inverse r square minus tan inverse second term, which is nothing but r square minus 2r plus 1. Tan inverse summation of r equal to 1 to 31 tan inverse r square minus tan inverse r minus 1 whole square, right? Again, we created a difference of two consecutive series where the terms will cancel out. Put r as 1. If I put r as 1, what is the answer I will get? Tan inverse 1 square minus tan inverse 0 square plus. Again, put r as 2. Tan inverse 2 square minus tan inverse 1 square. Again put tan inverse 3 square minus tan inverse 2 square. What is last term you will get? Last term you will get as tan inverse r is 31 square minus tan inverse 30 square. Now check any term cancel out. I can say tan inverse 1 square, tan inverse 1 square cancel out. Tan inverse 2 square, tan inverse 2 square cancel out. Tan inverse 3 square will cancel out with the next term. So how many terms left in the starting? Only one term. So in the ending also, only one term will cancel out. One term will left, right? Tan inverse 30 square will cancel out. So the left portion is nothing but tan inverse 31 square minus tan inverse 0. What is tan inverse 0? Tan inverse 0 is nothing but tan inverse 0 is nothing but 0, right? These two terms will cancel out, tan and tan inverse function. Answer will be 39 square. What is 39 square? 961. So answer of this question is nothing but the 961. So I hope these type of questions you can solve. Moving on to the next question. It is based on summation of inverse trigonometric series. Can you tell me the answer? Which option is correct? Solve it first and then tell me the answer. I hope you already solved. So let us see how to solve this particular problem. The formula was tan inverse a minus b upon 1 plus ab, right? I have to create 1 in the denominator, and denominator should be 1 plus product of two values. That number should be conjugate numbers, right? So how to create? What I will do, I will add 1 from our side. So I have to subtract also. So can I write this thing? I added 1, I subtracted 1. Is any factors are possible? See the factors. What are the factors? N plus 2, n minus 1, right? Check the difference between them. And then cancel out 3, right? So can I write the numerator as tan inverse n plus 2 minus n minus 1 upon 1 plus n plus 2 n minus 1. Now I can use this formula. Which formula? Tan inverse a minus b upon 1 plus ab is nothing but tan inverse a minus tan inverse b. Use this formula. So what I will get? I will get tan inverse n plus 2 minus tan inverse n minus 1. Now I will put the values one by one. Which value I will put? I will put the first value, which is nothing but n equal to 1. So if I put n equal to 1, this will become 3, this will become 0. So you will get tan inverse 3 minus tan inverse 0. Put n as 2. You will get tan inverse 4 minus tan inverse 1. Put again next value, n is 3. So what I will get? Tan inverse 5 minus tan inverse 2. Again put the next value, tan inverse 6 minus tan inverse 3. Next value, tan inverse 7 minus tan inverse 4. What is last time we will get? Tan inverse infinity plus 3 minus tan inverse infinity plus 2 minus tan inverse infinity minus 1. Check how many terms will cancel out. Can I say that tan inverse 3 will cancel out? Tan inverse 4 and tan inverse 4 will cancel out. Tan inverse 5 will cancel out in the next term. So how many terms left in the starting? 3 terms left in the starting, right? So 3 terms also left in the ending. What are terms left in the starting? The starting term is minus tan inverse 0, minus tan inverse 1, minus tan inverse 2. So 3 term here also. What is tan inverse infinity? Pi by 2, pi by 2, pi by 2. You will get 3 pi by 2 minus tan inverse 0 is 0, tan inverse 1 is pi by 4 minus tan inverse 2. What is 3 pi by 2 minus pi by 4? Take the LCM. So I will get what are the options? If you read the options, there is no option which is related to minus tan inverse 2, right? It should be minus sign. And remaining are the cot inverse. So what I will do, can I write tan inverse 2 as pi by 2 minus cot inverse 2? What is the answer of this? 3 pi by 2 minus pi by 2. Pi minus pi by 4. 3 pi by 4. So 3 pi by 4 plus cot inverse 2. That is your answer. Check which option is correct. I can say first option is correct. Because this answer is in terms of cot inverse 2. So this is how to convert any term as a difference of the method. Moving on the next question. Tan inverse 1 by 3 plus tan inverse 2 by 3 plus tan inverse to the power of n minus 1. So here the general term already they mentioned. What is general term they mentioned? Tan inverse to the power of n minus 1 upon 1 plus to the power of n minus 1. Up to infinite term, it means n started from 1 to infinity. If you put n equal to 1, you will get the first term. So how to calculate this difference method? One is already present. Can I write to the power of 2n plus minus 1 as to the power of n into to the power of n minus 1? Why write in this format? Because if you notice, numerator is to the power of n minus 1, right? What I will write numerator is to the power of n minus 1. So can I write? Just check, are these values are a and b? If I assume this is a and this is b, what is a minus b? To the power of n minus to the power of n minus 1. Anything common? To the power of n minus 1 common. 2 minus 1, which is nothing but 1. I got the numerator part, right? So I can write the numerator as to the power of n minus to the power of n minus 1. Summation n equal to 1 to infinity tan inverse to the power of n minus tan inverse to the power of n minus 1. Again we got the conjugative numbers. So again we will put the values of n and they will cancel out. Put n equal to 1. What is the answer? If I put n equal to 1, I will get tan inverse to the power 1 minus tan inverse to the power 0. Next thing, I will get tan inverse to the power 2 minus tan inverse to the power 1. Last term, tan inverse to the power of infinity minus tan inverse to the power of infinity minus 1. Check any term cancel out. First term cancel out the first term, right? Second with the second. Last term with the previous term. So what left? The left portion is tan inverse to the power of infinity minus tan inverse to the power 0. What is tan to the power of infinity? Tan inverse infinity to the power 0, tan inverse 1. What is tan inverse infinity? Pi by 2 minus pi by 4. Final answer will be pi by 4. So this is a new question where the summation is given summation is not given, where the series expressions are given. I have to find the general term. General term was already mentioned in the question, and I have to create the difference method. The I.T.F most probably questions are solved by the I.T.F series also. Moving on to the next question. It is given terms of cot inverse. Up to infinite term we have to find the summation. Here general term is not given, so we will try to find the general term of this question. So can I say that general term is nothing but cot inverse 1 square, 2 square, 3 square, any pattern, r square, plus 3 by 4 is constant in everywhere. Take the LCM. I will get cot inverse 4r square plus 3 upon 4. Do the reciprocal. I got this thing. What is Sn? S infinity. Summation of general term up to infinity. So this is our question. Now think how to convert this particular number in that format. Which format? The format is tan inverse a minus b upon 1 plus ab. So if I add 1 and subtract 1, then I can write 4r square plus 2, right? Nothing we can take common. We are not able to do the factors of this, so that it is converted to a into b format. So what we have to do? Try to think this question, how to convert in this format. Can I divide by 4 in the numerator and denominator? So what left? 1 upon r square plus 3 by 4, which is nothing but the general term, right? What I will do, I will add 1 and I will subtract 1. If I add 1, I have to subtract 1 also. So what is 3 by 4 minus 1? Which is nothing but 1 by 4. Check any factors are possible. Can I use a square minus b square? If I use a square minus b square, what is the answer I will get? 1 upon 1 plus n plus 1 by 2, n minus 1 by 2, right? How to convert the numerator? Can I write numerator as difference of these two values? N plus 1 by 2 minus n minus 1 by 2, 1 plus n plus 1 by 2, n minus 1 by 2. Check n cancel out, 1 by 2 plus 1 by 2, 1. So I created a difference method. I will get sin tan inverse n plus 1 by 2 minus tan inverse n minus 1 by 2. Now put infinity from r equal to 1 to infinity. What is the answer I will get? I will get tan inverse 1 plus 1 by 2 minus tan inverse 1 minus 1 by 2 plus tan inverse 2 plus 1 by 2 minus tan inverse 2 minus 1 by 2 up to infinity. Don't you think tan inverse 3 by 2, tan inverse 3 by 2 cancel out? tan inverse 5 by 2, tan inverse 5 by 2 cancel out. How many terms left? There are two terms left. One term in the starting, one term in the ending. Which term in the ending will left? Nothing but tan inverse infinity plus 1 by 2 minus tan inverse 1 minus 1 by 2 is 1 by 2 also. Tan inverse infinity, which is nothing but pi by 2. So pi by 2 minus tan inverse 1 by 2. Can I write cot inverse? Pi by 2 minus cot inverse 2 is nothing but tan inverse 2. That is your final answer. Moving on the next question, which is 2 upon n square plus n plus 4. How to solve this problem? Same thing. I have to think how to convert the denominator in the format of 1 plus ab. If you are able to think, the question will be very simple. Summation of n equal to 1 to infinity tan inverse, it is nothing but 2 upon n square plus n plus 4. So what I will do, if you look, I have to create 1, right? How to create 1? If I write 1 plus n square plus n plus 3 as a denominator, this will not work out because we don't know the factors of this. So we have to use something so that we are able to convert. What I will do, to make it 1, I will divide by 4. If I divide by 4, what is the answer I will get? 1 plus n square plus n divided by 4. Numerator will be 1 by 2. 2 divided by 4 is nothing but 1 by 2. Tan inverse 1 to infinity. Tan inverse. Can we do the factors? N square plus n by 4. What are the factors? N common. Can I write n by 2 as well as n plus 1 by 2? Right? Numerator, can I write n plus 1 by 2 minus n by 2? Here n by 2 cancel out in the numerator, only 1 by 2 left. So it follow the pattern. Which pattern? The pattern of tan inverse a minus b upon 1 plus ab. What is formula? Formula is nothing but tan inverse a minus tan inverse b. So what is the answer I will get? I will get as tan inverse n plus 1 by 2 minus tan inverse n by 2. Put n equal to 1, 2, 3, 4, 5. What is the answer? If I put n equal to 1, I will get tan inverse 2 by 2 minus tan inverse 1 by 2. Again, if I put n as 2, I will get tan inverse 3 by 2 minus tan inverse 2 by 2. Next one, tan inverse 4 by 2 minus tan inverse 3 by 2. What is last term I will get? Tan inverse infinity plus 1 by 2 minus tan inverse infinity by 2. So as we can say, first term, second term cancel out, second term with the third term with the fourth term, last term is cancel out with the previous term. How many terms left? There are 2 terms left. One term is nothing but tan inverse infinity minus tan inverse 1 by 2. Again, what is tan inverse infinity? Pi by 2 minus tan inverse 1 by 2 is nothing but cot inverse 2. What is pi by 2 minus cot inverse 2? Which is nothing but pi by 4. Which is nothing but tan inverse 2. So this is your answer. in all these questions we have to use a method of difference method. I just have to create the difference of inverse trigonometric functions so that they will cancel out, right? Moving on to the next question. Again same pattern. First we have to find the general term. What is general term? Tan inverse 2 is common in the numerator, so numerator is 2. What is denominator? I square. Now how to create the difference? Can I write up to infinity term? So S infinity is nothing but summation of R from 1 to infinity. Tan inverse 2 upon R square is given, right? So how to create R square as 1 up 1 plus AB, right? Can I write R square as R square minus 1, add 1? So that denominator will balance. Can I write the numerator as? What are the factors of R square minus 1? R plus 1, R minus 1. So numerator is also R plus 1 minus R minus 1. A very simple problem, right? Put again the formula. What is formula? Tan inverse R plus 1 minus tan inverse R minus 1. I just created a difference method. Now I have to put all the values. Put R as 1. I will get tan inverse 2 minus tan inverse 0. If you notice, there are two difference, right? Difference of 2. So 2 terms will be left in the starting and 2 terms left in the ending. What are the terms are going to be cancelled out? Tan inverse 2 with the tan inverse 2, tan inverse 3 with the tan inverse 3, tan inverse 4 with the next 5, tan inverse 5 with the next one. 2 terms left in the starting, so 2 terms left in the ending also. What are the terms left in the ending? Ending terms are pi by 2 or pi by 2 or not? Minus, what are starting terms? Tan inverse 0 minus tan inverse 1. I got here pi. This is tan inverse 0, 0. Tan inverse pi, tan inverse 1 is nothing but pi by 4. Pi minus pi by 4 is nothing but 3 pi by 4. So in this question, the answer is nothing but 3 pi by 4. Tan inverse 2 upon 1 plus s square, tan inverse 2 upon 2 square, tan inverse 2 upon 3 square, up to infinite term. We can also find up to n terms. Last term will be different.